Welcome back. So far we've been having quite a lot of videos on just the intuition of derivatives. And in my opinion, this is the most important thing because then once you have the intuition, everything else is much easier. However, we do have to cover certain rules in derivatives because here's why. So this is our definition, right? That's how we calculated our derivative. But we have many functions and some of them are very complicated. And to apply this rule every time, well, it would be very tedious. So what the mathematicians did a long time ago is that they said that, okay, let's see if for certain cases we can create some kind of rules, and if we can mathematically prove those rules, then they will simplify our lives greatly. We're going to talk about some rules that will enable you to take derivatives of functions faster so that you could avoid taking this limit all the time, and so that you could speed up your derivation process. But before that, I want to very quickly cover differential operators. Okay, first of all, what is an operator? Well, an operator is something that creates an operation. So let's say addition is an operation and we mark it with a plus sign, right? Or subtraction, we mark it with a minus sign. Or multiplication or division, either with this sign or with a slash, or we just say like 2 divided by 3 as a ratio. But division, it's also an operation. So let's say if I have two numbers, I have 2 and 3. If I perform an addition operation on those two numbers, then I would add those numbers and I would get 5. If I perform a subtraction operation on those two numbers, it would be 2 minus 3 equals minus 1. And then multiplication and division. Also, when we take a function is an operator. We have some kind of input, let's say x, and then we have an operator, just like addition, subtraction. These are operators, and this can also be considered as an operator. And then you operate this on x, and then you put x inside, and you get some kind of output, which is y. And also, taking a derivative is an operation. And just like any other operation, it has an operator. And that's the other reason why I like this notation better than, for example, apostrophe. So a differentiating operator is something like this. D, D, and in the denominator, you put input, and in the numerator, you put your function. And that's your operator, differential operator. So you differentiate a function like that. So it means that you apply this operator to a function, and this operator then differentiates this function with respect to that input. So if I have, for example, y equals x squared, right? And then I can say that my differential operator is dx. So what I do, I apply dx on y, and I apply dx on x squared. And then I will have dy over dx equals, and then either using the limit or some kind of rule, in fact you would use a power rule, then you would get 2x. You have some kind of function and you apply some kind of operator to it, and then you naturally see, because you treat it as a ratio, so you naturally see, okay, if I take dy over dx, so now this becomes dy over dx, and then it equals to 2x, which is the derivative of x squared. And for example, in the previous example, we wanted to find d theta dy. It was that beam example, right? D theta dy. So our main problem was to find this, but then we couldn't because we had this relationship sine theta equals y over r, and r was constant. So essentially what we did, we applied an operator which was d dy, and we applied it to the function sine theta, and then we also applied it to 1 over r and y. So on this side, okay, we treated sine theta as k. So we had something like this. We had k equals sine theta, so we had dk over d theta, and then we had d theta over dy, and this turned out to be cosine theta, and then we left this as the variable that we wanted to know. And here, look, if you apply this operator here, then you would have something like this. D, and this is one of the rules that we're going to see later on, which is the product rule, where you apply first of all d dy to 1 over r, which is a constant, and you keep y unchanged, and then you keep 1r unchanged, and you apply this operator d dy to y. And notice that if you take a derivative of a constant, then it would be 0. So this would be 0. So 0 times y, everything would be 0. And here, it would be like this. 1 over r times dy dy. But dy over dy is 1. So you're left with 1 over r. So that's how you work with the operators. And the other thing that I want to mention very quickly is that, can you take a derivative of a function only one time? Well, not really. Let's say that we have, again, this airplane example, but now let's say that we're going to have distance that equals 2 times time cubed. And then if we take the derivative of d with respect to time, well, we would get 3 times 2, which is a power rule. A power rule means that this 3 or any other power goes here. And then you have 3 times 2 equals t, and then here it would be 3 minus 1. So it's always, you take the power, you put it in front of whatever you have here, and then you subtract 1 here. And then you would get 6t squared. Now 6t squared, that's the change of distance with respect to time, right? Which is speed. But on the other hand, what if we take this derivative again? What if we apply this operator again? What if I just do it like this, d dt, and now this is my operator, and I apply it to dt over dt. So what will I have? I will have a double derivative, right? So you see you have two d's here, and that's why they denote it like this, d squared and d, and then you have two dt's here. So you have dt squared. And now this is a double derivative. So the double derivative is a derivative that you take from the first derivative. So if this is my first derivative, and in this example it's speed, if I take a derivative of this function, then it would be dd squared dt squared would be 2 times 6, which is 12, times t. But what is it? What is a double distance derivative with respect to time? If I take this derivative once, then I have velocity, right? The change of distance in a certain direction with respect to time, it's velocity. But if I take the change of velocity with respect to time, then I get acceleration, right? And what is acceleration? It's just how much the speed changes with respect to time. So if you have some kind of straight line function for the velocity, so you have time here and velocity here. And by the way, speed and velocity, they're not quite the same. Speed is how fast you go, and velocity is how fast you go and in which direction. So velocity would be a vector and speed would be a scalar. And then let's say if you have this straight line function here, then if you take delta v with delta t, then it would just be, again, nu minus old, the same story. You would have acceleration, so you would have v new minus v old divided by the change in time. From units, you will be able to see that it's going to be meters per second in second, right? So it's 5 meters per second minus 2 meters per second equals 3 meters per second. So let's say in 1 second, the velocity has changed 3 meters per second. And that's why acceleration is denoted like this, s squared. That's because it's m over s, which is m s s. So you see, a double derivative gives you, in this case, acceleration. However, it's just this example. You can have completely different variables, and then the derivative would just indicate their changes. So in fact, you can take as many derivatives as you want until you reach 0. So you see here the power has decreased, so now you have 6t squared. You took another derivative and you have 12t. If you take another derivative, which would be the cubed distance dt cubed, well, that would just be the change of the acceleration. It would tell you how much the acceleration changes, and that would be just 12. You can also take the fourth derivative, and then if you take the fourth derivative, delta 4d over delta t4, then you would have 0. So you just need to remember that taking a derivative is just taking a change. Every time you take a derivative, you get the change of that function with respect to the input. Okay, and now we're going to start discussing some rules.